In this tutorial video, we'll learn about a simple data structure, namely a one-dimensional array of integers, of strings, of boolean, of characters, or of any data type. And we're going to show you exactly how you can create a new array, how you can initialize it with a certain size, and how you can initialize all the elements to be certain values, and how you can manipulate the values using a loop. So that'll be kind of the plan for this video and the next one or two videos. Okay, let's create a new project for this particular lab, which will be lab 3. Let's create a new project here. So file, new, and Java projects, and let's type lab 3. Okay, and then under lab 3, let's start with a simple integer array. Let's say this is the integer array that we would like to start. Think about an array as just a linear, basically a horizontal visualization of a list of numbers, in this case integer array. It could be a horizontal list of maybe string values or boolean values or character values, can be any type. So now in this case, we're just going to say we have a horizontal arrangement of, let's say, 10 values over here. We got 940, 880, and etc. So we got 10 numbers. And as we briefly mentioned in the lecture, we say that the red numbers over here are the indices of the array. So the array indices always start with the number 0, always the case. I'll explain to you a little bit about into the inside of the convention why having index 0 is the way to go. It has to do with how the computer memory is actually arranged under the hood. I'll briefly explain that to you in just a moment. So indices always start with 0, and then the last index over here is 9. So now, based on this information, so we got the integer interval 0, 1, 2, 3, 4 up to 9. How many indices do we have in this case? In this case, that'll be 1 up to 9 will be 9, plus the index 0 plus 1, so we got 10 numbers. So always, the last index value plus 1 will tell you how many elements there are in the array. Okay, that's a principle you want to remember. Okay, so now for this particular example over here, we'd like to show you two ways to actually initialize the array, namely how you can use the initializer expression to initialize your array, which is the simplest one. And the second way will be a little bit more general, but a little bit more verbose in this case, which is to create an array of size 10, and then gradually assign each element, maybe position 1 at index 0 to 940, and also the slot at index 1 to 880, and etc. And 10 different assignments. So we're going to see approach 1 and approach 2 first in this video. And then next video, we'll try to see another array with a little bit more pattern that's involved, in which case we can use a loop. Okay, that's kind of the plan. So now what I would like to do, I'll refer back and forth to this array for our reference. And one more thing to say. Whenever we draw the array, we simply say, let's say the variable name for the array is simply IA, standing for integer array. So IA is simply pointing to just an array like this, into the beginning of the array. That's just convention we're going to draw. Okay, so now let's go back to Eclipse, and then let's create a new class. Okay, we'll simply right-click on the source, and then say new, and then class. Okay, so now for the first class, let's call it integer array. Integer array, let's say number 1. Okay, and then we'll simply click on the main method to be generated, and then we'll say finish. Okay, let me maximize the tab over here, so we'll start from here. So now we don't need any user input. I just want you to get familiar with the syntax of declaring the type of the array, how you can initialize the array using approach 1, which is initializer. And then we'll try to see how we can just use a simple loop to actually print out the value of the array. Okay, so now that's the simplest I want you to get. So now, how do we declare an array? In this case, one thing to remember. Okay, let me write out the rule for you. For any given array, okay, always remember two principles. Number 1, indices always start with 0. Okay, indices always start with 0. So which means over here is always start with 0. Okay, 0, 1, 2, etc. Okay, the size of array is the last index value plus 1. So what do I mean by that? You can see for this particular array, what's the size? It's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The size is 10. 10 is exactly the last index, which is 9 plus 1. Okay, this is always the case. Let's say if you have an array of, let's say 100 elements inside. Okay, 100 is the size. So what will be the last index? So the first index is 0, as always. And the size is 100, so that means the last index will be 100 minus 1, which will be 99. So from indices 0 to 99, we got 100 elements. Okay, so this is kind of the index pattern you want to get used to for any problem you want to solve on the array. Okay, let's go back here. So let me write down another principle for you. I may extend this list a little bit later. So number 3, each element for any given array, okay, so for any given array, so over here, every element, each element, or all elements are of the same type. For example, you can have an array of all integers, you can have an array of all string values, or you can have an array of all Boolean values. However, you cannot have an array that stores both integer, string, and Boolean and character. It's not possible. It's homogeneous. So you always have to store the same type of element. That's a constraint for the array. Okay. So now let's have a look to see how we can create this particular array. I will show you the visualization is already here, but I'm going to show you how you can see the array in the debugger, which will be very important for you as a programmer to actually debug your program later. Okay, so let's see. Approach number 1, initializer. As we can see over here, initializer simply means we explicitly enumerate all the elements in the array from the leftmost to the rightmost. Okay, so let's try that. So now to really have an array initializer, we can do this. First of all, we know that each element in the array is of type integer. Okay, we first of all put the integer over here. But if you only say integer, let's say IA, and then it's assigned to something. This is what you are used to from the previous tutorial video. If you only say IA, supposedly that's integer array. If you only say int over here, that simply means IA is a single integer value, right? That's how we declare an integer variable. But that's not the case over here. We want to say IA is actually pointing to the beginning of a linear structure, an array of integers. So it's multiple integers we're talking about. So the type over here should be expanded. So the syntax we want to learn for this expansion is opening square brackets and closing square brackets. Okay, so that's the syntax you want to remember. Okay, nothing inside. So this integer, this int opening square brackets, closing square bracket over here simply means it's an array of integer type. Okay, and then we're going to say we're going to initialize it. Okay, so now opening curly brackets and closing curly brackets, and then we put a semicolon to end the statements. If you simply put nothing inside, it simply means it's an empty array. Empty array simply means it's an empty collection. Nothing is inside. But in this case, we do want to store 10 different elements inside. So let's simply put them out. So I'll just put 2 by 2. 940, 880. Okay. So we'll put 940 separated by comma, 880. Okay, and then we got 830, 790, 830, 790. Okay, and then 750, 660, 750, 660. Okay, and then we got 650, 590, 650, 590. Okay, everything is separated by comma. And then also we have 590, 510. 590, have I missed anything here? So 590, 510, yes. 590, 510, and then 440. Have I missed anything? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we got exactly 10 integers. Okay, but in case I got anything wrong, I'm just doing that quickly. In case I got any numbers wrong, you can fix it. Okay, it's getting the numbers right is not the point. Okay, so now I'm just trying. So this is called array initializer. So I'll simply say approach 1. This is so-called array initializer notation, which means it's comma separated values. Okay, you can see every element is separated by a comma over here. Okay, and then you can see after the very last elements over here at index 9, there's no comma after that. Okay, so this is the element at index 0, index 1, index 2, index 3, index 4, index 5, index 6, index 7, index 8, and index 9. Okay, so we got 10 elements over here. So now let's see something very basic. What's the size of the array? There is a way for you to check. So that's another thing I want you to learn about the syntax. Okay, we can say system.out.println. Okay, over here we can say size of the array IA, which is called integer array, right? Why don't we simply say we have some escape sequence over here for you, so we can know the name. Okay, and now that should be, in this case, that should be IA, which is an integer array variable. If you say dot, okay, so now Java supports certain methods or things you can actually call. But for now, if you actually see this long drop-down menu list, don't panic. You don't have to worry about them for this course. Okay, the only thing I want you to know is something called length. Okay, length, which means how long the array is. In this case, how long is the array? Well, it's exactly 10 elements over here. Okay, and now I want to say one more thing. System.out.println. Okay, so first index of the array IA. Okay, you can do the crop, but for now I'm just won't do it. Okay, it just takes time. Of array IA is, okay, for the first index is always 0. Okay, so here this is not so interesting. However, I want to show you what's the last index. Okay, so now the last index of the array IA is, so now think about what's the relation. The size of the array over here is 10. So what should be the last index? Given that the first index start with 0, what should be the last index given that the size is 10? 10 minus 1. Okay, so over here, the last index of the array is simply, now I can put something here that will just calculate. And then I'll simply say ia.length and then minus 1. Okay, so now you just want to make sure you bracket as well. So you want to put this particular calculation over here in brackets. Okay, so now what are we trying to say here? We're saying that ia.length in this case is going to tell us how many elements there are in this particular integer array, in which case it's going to give us 10. Okay, and then so this expression over here is going to give us 10. And of course, if we change ia to be another initializer, let's say with only 5 elements inside, then ia.length will just give us 5. So it depends on which array we're talking about. And then ia.length minus 1 will be just 9. Okay, let's try this right away, and then we'll see a little bit on the debugger, and then we'll try the loop to really print out everything from the array. Okay, so now what we'll do is we'll simply just go back to this package explorer over here, and then right click on integer array1.java and say run as Java application. So what you will see is size of the array IA is simply just 10. Okay, and the first index is 0. And ia.length is 9. Notice the most important part for you to understand. Let me recap the syntax. First of all, you should know that integer with opening square brackets, closing square brackets simply means the array of integer type. And then for the array initializer expression, you can say curly brackets, closing curly brackets, and comma separated list of values of the correct type. Of course, if you simply put something that's not an integer, because every element in the array should be an integer. If you simply put, for example, if you simply put a character A, so this is not right. Okay, so now if you also put, for example, string array, let's say if you simply put string, let's say ABC. Okay, this is apparently wrong, right? You can even see the red underline over here. It simply say type mismatch, cannot convert string into integer, because we're expecting every element in the array to be an integer, but now you're putting a string. Okay, that's simply not right. Okay, let me just undo it. Okay, so now, and another thing to notice is every time you give it an array variable name, you can say .length to know how many what the size of the array is. What's the maximum capacity for you to store store values into the collection. And then always, if you say the size of the array minus 1, okay, this is a very important formula for you to know, which is not difficult. Given that the index always start with 0, if you know the size of the array, what should be the last index? Exactly the size of the array minus 1, which will give you, in this case, 9. Okay, let me show you something very quick. So now, if I simply just delete this particular element there, so now, what's the size of the array? So now the size of the array becomes 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? So that means IA the length is now going to become 9. I haven't changed anything yet, but IA the length is just going to print out the result accordingly for me, okay? So now what will be the last index? So now if I got only 9 elements in the array, the last index should be 8, all right? So now IA the length is going to give me 9. So IA the length minus 1 will just give me 8. Okay, let's double check. If I run the application, you can see the size of the array is simply 9. And then the last index of the array, which is 9 minus 1, which should be 8. Okay, hopefully you're comfortable with this. Let me undo it. Let's see very quickly on the debugger to see how the array looks like. It would just correspond to exactly how I visualize this to you. But the only difference is the way we present the variable structure in the debugger in Eclipse is vertical, as we saw before. But the way I drew it visually is horizontal. Okay, they are just consistent with each other. You just want to get comfortable with both. So what I would do is I'll simply just put a breakpoint. Remember how to put a breakpoint? I simply just put it line number 13 over here. It's right before I declare this particular integer array variable over here, right before that. So it doesn't exist just yet. So what I will do is I will double click. So now I will right click on this particular class, and then I will say debug as Java application. Okay, that's what I will do. And as soon as I say that, so now I'm switched to the debugger perspective, right? Remember, we got Java perspective, and also we got debugger perspective. So now I'm at line number 13, right before I try to declare this particular variable IA. So now if I say step over here, step over, as soon as I say that, it's going to create this particular IA as an array of integer, and then it's going to initialize it exactly like this. Okay, let's verify that. So if I say step over, so now you can see that IA, okay, let me just get a little bit bigger for you. Okay, you can drag it down, drag it over, drag it up. So now you can see IA can be expanded. If I try to do that, you can see this corresponds to exactly how I try to draw over here, okay? To see which, you want to get comfortable with both, okay? So now you can see this square bracket 0, which means what's really stored at index 0. What is stored in index 1? What is stored in index 2? You can see 940 is exactly the value that is stored at index 0 of IA, integer array, right? You can also click on this IA over here. It's just going to show you some nice representation of the array. So that's exactly 940, 880, all the way to 440, right? Exactly how we wanted to set it up. Okay, let me try the expressions over here. Of course, you can just count to see how many elements there are. You can see starting from index 0 all the way to index 9. So we got 10 elements. But I do want to go to expressions over here. Again, if you don't have the expressions view, you can go to window and show view, and you can go to expressions. Okay, so now let me just delete the previous ones. Okay, I can simply go to let me just click on this and then right click. Okay, and then I'll simply say remove all. Okay, and then say yes. Okay, let me just close this. So now let me add a new expression here. For example, I can say IA dot length. Okay, it's going to tell me 10 because I got 10 elements in the array. So I can say IA dot length. Notice a very common mistake. If you simply say IA dot length and then with parentheses like this is wrong. There's no such notation. Okay, if you simply do that, it's going to say error. Okay, it simply cannot be evaluated. Okay, it's a very common mistake. Okay, and then I can say IA over here at position 0. So basically opening square brackets and closing square brackets, and then I pass down value of the index over here. The first one is simply 0. So I can try that. Okay, you can see the first element there is 940. Okay, and if I try the last one, let's say IA. So now I want to go to the last elements. How can I do it? I can say so here I can say 9 for sure, but let's try some formula, a little bit more complicated expression over here. Give it a try as well. I can say IA the length, which is going to give me 10. However, notice that if I simply say this, it's going to tell me error. Why is that an error? IA the length is going to give me 10. However, do we have index 10 over here? No, the answer is we don't. The last index of any given array does not correspond to the size. It corresponds to size -1. So what we should do is we should say ia.length -1. Okay, that will give us the last element, which is 440. Okay, so a very quick illustration on the debugger. Okay, so now we have seen this from both the variables and also from expressions. You really want to get used to this as quickly as possible, so that later on when you do the lab test or to do the lab exercises, you will know how to debug your program involving array. Okay, let me just stop this and then let me switch back to the Java perspective. Okay, you want to click on the top right corner over here to Java. Okay, so now let me just say one more thing, and then I will show you some interesting stuff about hardware. So how do we print out the elements of the array? We can say system.out.println. Okay, let's say elements of IA integer array at index 0. Okay, and then over here I can say IA at position 0. So this is how the syntax you want to learn. So you put the name of the array and also opening square brackets and closing square brackets, and then you simply put the integer value over here. The first one should be 0, right? Starting with 0. Okay, and then let's say over here I'm going to try to print out everything over here. Okay, it's going to be tedious, but that's exactly why we may use a loop to automate it, which I'll show you in just a moment. Okay, element at index, okay, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's do it exactly what we're supposed to do here. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, here let's change that accordingly. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And just as a reminder, for this one, it's equivalent to ia.length -1, right? Remember? Okay. So now let's try to print it out, and then I'll show you some insight into why we are writing this particular kind of notation. Okay, so now let's just execute it. So now if I just run the Java program, not with debugger, just run it as normal. Okay, it's going to tell me that, you can see over here, element at IA at index of IA at index 0 is 940. Okay, 940 you can see over here, and 940 here. The next one should be 880. Over here, 830 over here. Okay, you can see the idea. And the last one should be at index 9, should be 440 over here, and that's 440. Okay, everything just matches. So we created a new array of type integer, and then we simply just want to print it out. And we do it the very naive way, but we want to automate it in just a moment. Okay. One more thing to mention before I show you some insight into the indexing notation. Okay. So now, there's one drawback of using this initializer notation. So we said this is so-called initializer notation over here, which means I can simply initialize this particular array to be this particular structure, right? Like this. Okay. However, since we talked about before, any variable may be reassigned to any other value, right? Since this IA here is simply just an array of integers, so at the moment it's simply just pointing to an array of size 10. It can definitely be reassigned to another array of size maybe 20, and then later on be reassigned to another array of size 100, right? However, you cannot reassign an array to another initializer notation. So what do I mean? So now let's try this. Let me just write down the rule for you over here. Limitation. Constraint. Okay, let me just spell it properly for you. Constraint on the array initializer notation. Initializer notation. You cannot reassign an array using the initializer. However, later on, as we'll see in the next video, if you use approach 2, which is to use just individual assignments, in which case you can actually use reassign the array using the same notation. But for approach 1, for initializer, it's only for initializing the array just once. But if you want to reassign that particular array variable to something else, you cannot use initializer anymore. Okay, let me demonstrate to you why. Alright, there's no why, just the rule for the language. But let me illustrate to you exactly what I meant. So now I have IA over here, which is already declared over here, right? So now let's say rather than having an array of size 10, I want to reassign that into an array of size, let's say 9. I simply want to get rid of the last elements as I did previously. You can see now conceptually we know what we really meant to do, what we really are trying to do over here. I simply say IA, rather than pointing to an array of size 10, I'm trying to reassign that into another array of size 9. That's what I'm trying to do here. However, this syntax over here simply doesn't work. Okay, it's just not allowed. Okay, let's see. Move your mouse over. Array can only be used in initializers, which means you just cannot do it. Okay. So now I will just comment this out to really give you a warning over here. So you can definitely try to initialize the array for the very first time using the initializer notation. That's fine. But later on, if you want to reassign the same variable for the array, you cannot use the notation anymore. Okay, but what should you do? See the next video. We'll get into it. Okay, so now let me just explain a little bit about this particular indexing notation over here for the array, and then I'll show you how you can automate these 10 lines over here using a loop. And then we're done with the video, and then we'll just try to go with the second approach. Okay, so now I want to really give you some insight over here. Okay, so now if you look at so we talk about indexing of the array. Okay, so over here, indexing of an array. Okay, you can think about over here. Let me just copy some diagram from my previous page. Okay, let me just copy this particular array diagram over here. I'll use it. So this is the conceptual model you should have. And then we'll compare that side by side with how it is stored in the hardware. Okay, let me just try to copy this diagram over here. Okay, good, it's copied. So now if I just put it over here, okay, it's a bit too large. I can just make it smaller. Okay, I think this will be reasonable over here. Okay, let's talk about this particular array. Okay, so now the array name is simply IA. That's the name of the array. Okay, remember the way we created was I simply say integer array over here. IA is simply assigned to a comma separated list over here. I just omit the details inside. Okay, so now think about how this particular array will be stored in the computer memory. Any data you actually want to manipulate in your program will be stored in your computer memory. I don't want to touch too many details about the computer memory, but computer memory you can think about is a sequence of bytes, just a sequence of cells that you want to store. Okay, and every cell in the array, every cell in the memory simply got some memory address. For example, so we talk about computer memory over here. Okay, computer memory, and it looks like this. It's simply just a sequence of cells over here. Okay, and then each one of them simply got some address. For example, you can see over here we got one address over here. The value for the address is only for illustration. Okay, so now you can see this one here 067C1. The next one simply just plus 1. You can go from 1 to 2, 2 to 3, 3 to 4, and all the way to 8. Okay, that'll be enough for the illustration. And then this address might go on, and also there might be some previous address before that. Okay, just some memory address. So now, when we actually declare an array variable IA over here, what does that mean? That means we're going to store the array starting from certain address in the memory. In this case, let's say, for example, we simply start with this particular memory address. So this is the start of the array. Okay, so this is the start. Okay, let me put a note over here. So this is the start of storing contents of the integer array IA. Okay, just the starting points. Okay, so now one more thing to say. So there is certain thing about the size of the value you want to store. For example, for integer specifically, so again, it's only for your information. Every integer takes 4 bytes to store. Of course, it's only for your information. You don't have to memorize it. What does that mean? That means for every integer over here, for example, 940, in order to store its value, is going. You can think about each memory cell is 1 byte. So now, if I want to store 940 over here, so it's going to take up 4 bytes. Okay, so now let me write it down. So you can think about, so this is the first byte, 2, 3, and 4. So this will be used to store the first number in the array. What about the second number? The second number in a similar manner, so this will be a second number. We'll take up the next 4 bytes. 1, 2, 3, and 4. Okay, so now, so far we talk about 8 bytes. Okay, so now, let me just write it down for you. So this will be store the first number, the first elements. Okay, and then this next 4 bytes will store the second elements. Okay, I want you to see one more thing, and then I can derive the indexing notation for you. Okay, so now, okay, and each element is 4 bytes, right? For integer, 4 bytes for integer, and also this is also 4 bytes for integer. If you're curious about how large for each data type is going to take, for example, integer will be 4 bytes. If you talk about, for example, double, it's going to be I forgot, maybe it's like 8 bytes, like 32 bits. Okay, so you can actually look up the your slides for the elementary programming lecture. Okay, but anyway, for integer, for your information is 4 bytes. Okay, and 4 bytes for the integer. So the units of storage, is simply in this case 4 bytes. Okay. This 4 bytes is really important over here for the critical to understand the indexing notation in this case. Okay, so now let's see this. So now we know that what's going to be the starting address for the first elements. The starting address for the first element is simply this address over here. Okay, what about the second? What about starting address for the second number? In that case, it would be simply this address over here plus 4, right? In that case, it would be, because we know that the next 3 bytes will simply just be the green one, which will be for the first number still. But if I say plus 4, which will give me 0, 6, 7, C5. So this is starting points for the second number. Okay, let me write it down again. I know it's a little bit tedious over here, but I do want to explain to you so that you really have some insight into the indexing notation. Hopefully you just wouldn't get it wrong from now on. Okay, so this is the starting address of the first elements. Okay, on the other hand, this one here is the starting address of the second elements. And the absolute value for the address is not really critical here, but the most important thing is this minus this will just be 4. Okay, now I'm really getting to the points. So now I want to explain to you why the way why we have the way that we index into the array. For example, specifically, you can see over here we simply say if I want to refer to the first element, I'll say IA and then index and then 0. If I want to go to the next one, I'll say IA and then 1. Okay, let's see exactly what it means. So this is how we can interpret that. So now if I have the first elements, if I want to get to the first elements in the array, I would say IA and then 0. Okay, this is how you can understand the idea. Okay, for those of you who might learn about C programming later for your major, this is kind of the insight you want to get into, because C is actually going to manipulate the array in a way that's more powerful than the Java called pointer. But that's something you can just look up by yourself. That's off the topic. Okay, over here, so now let's think it this way. IA over here is the variable name for the array. So this is the starting address. It's the starting address of the array. And the 0 over here, you can think about this is the number of units of offsets. Okay, let me try to explain to you what I mean by this. You can see that the starting address over here, as we said before, the starting address for the array is simply 0x7c1. Okay, that's the starting address of the array. At the same time, it's also the starting address for the very first element, right? Okay, so now, so the number of units of offsets, what's the units? As we said, is 4 bytes, right? Every element takes exactly 4 bytes in this particular array. So now, if I want to calculate what's the address for the first element, so this tells me exactly how I can calculate. So this starting address for the array plus this is the units for every element, 4 bytes, multiplied by whatever this number, which is the number of units of offset, which means starting from the starting point of the array, how many units should I go in order to go to the particular element I want to really calculate? If I want to go to the first element, this is it. If I want to go to the second element, I need to go for the offset of 4 bytes. If I want to go to the third element, I want to go to an offset of 8 bytes. Okay, that's kind of the idea. So now that's basically 4 times 0. So this will give to me exactly 0x7c1. So this tells me the address for the first element is simply this, which is exactly this. Okay, let me give you another example. What about how to calculate the first elements? So now let me give you, what about blue? Okay, we know that it should be this particular address here, but how is it calculated? So now what you will have to write is, if you say second elements over here, okay, the way you write it would be IA, the variable name, and also square brackets. If you want to go for the second element, you should really say 1. So 1 here simply means the following. Okay, I want to go to the starting address for the second element. In this case, it's simply this. And think about how many offset you should really have from the starting point of the array. Well, you have just 1 offset, right? Because the very first segment of the array is reserved for the first elements. You want to go bypass that one, and then so go to the second elements. Okay, in that case, what we would do is we would say this simply means the following. Okay, the starting address for the array, we know that is simply 0x7c1. Okay, plus, and this part over here will just be the number of units of the offset. So now the units of offset will just be 4. Every integer is 4 bytes multiplied by 1. So this is the number of offset because it's simply 1 unit away, right? Only 1 unit away, and we get to the starting point of the second elements. Okay, multiplied by 1. So what do we get? You simply get 0x7c, 1 plus 4, you get 5. So this is the starting address for the second elements over here. Right? This is exactly how the hardware works, especially if you program in the C language. But in Java, it's simply part of the C family languages. That's why they inherit this notation here. So now, what's my point here? My point here is, I'm really trying to explain to you why we have this kind of convention over here to say if you want to get to the first elements, you have to say IA at position 0. If you want to get to the second elements, you want to say IA at position 1. Of course, you can always remember, if I want to go to a particular position, simply -1, that would tell me the index number. True, that's how I would do it. However, it might be worthwhile for you to understand how exactly this is supposed to calculate the starting address for a particular elements, given this kind of memory setup. Okay, so I would say it's worth, it's just broaden your knowledge. Okay, so I'm just mentioning this just for your interest. Okay, but now the bottom line is, from now on, I'm going to assume you're comfortable with this particular indexing notation. If you always go to the first element using index 0, you go to the second element using index 1. If you want to go to the nth elements of a particular array, let's say IA, you had to say IA at position n-1. Okay, it's always the case. But now, if you try to really think about the way we calculate offset of the address, hopefully that will help you remember in case you forget. Okay, so now finally, I would like to show you one more thing before I end the tutorial video. I want to show you how you can make these lines over here shorter. Okay, as you can see, we are basically repeating the same actions over here, or very similar actions. As we say in the lecture, if you find that you're repeating similar actions over and over, it's a very motivating scenario for using loops. Okay, and now we know exactly how many lines we have to repeat. So now it'll be a very good scenario for using a for loop. Okay, so now what we can do is, why don't we try to automate it? Okay, so now my first approximation will be, basically we start with the value 0 over here until we get to 9, right? So why don't we try to write a for loop? I'm going to show you two for loops which will work, both of them. Okay, so now the first version over here. Okay, let me just go a little bit more space over here. Okay, so now the first one, we can simply say for, we can say integer I would be simply 0, starting from 0, I less than or equal to 9. That would be the last number, I plus plus. Okay, I can simply say, you know what, I'll simply just copy this line here to help me a bit. And then I can say over here, element IA at index, okay, whatever it is, for I. Okay, so now you can see for every iteration of the loop, the value for I is going to change from 0 to 1, 1 to 2, 2 to 3, and etc. Okay, so now that's what we have. Element of IA at index I over here, depending on which iteration we have. For the very first iteration, I will be of value 0, and the last iteration I will be of value 9. Okay, and over here, of course, over here, this is the part you really want to get comfortable with. So here, rather than having a concrete value, a very specific value over here, we're going to say just I. Okay, I'll run the debugger with you to get some idea. Okay, so this is going to work. So notice what we have done here. We simply we observe that there's certainly some pattern for the way we are repeating this particular 10 lines. So that's why we can simply say, okay, rather than having these 10 lines, why don't we simply get a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and also the 0, 1, 2, 3, all the way to 9. Why don't we move them to a loop counter value? Okay, that's exactly what I'm doing. So I got a loop counter I starting from 0 until 9, and then I'll increment the I value every time. Okay, so now let's see exactly how that will execute into. Okay, for now, I'm just going to comment out to avoid distraction. Okay, you can select the block and this control/. Okay, so now we'll see exactly what the output is for this particular block of code. Okay, it's gonna work. So now let's simply say run, and then I simply got, okay, elements at index 0 is 940. Okay, you can double check 940 over here, and then at index 9 is simply 440. Okay, let's run a debugger quickly and show you how. And then I'll show you one more loop, and then we're done. Okay, let's move the mouse. Let's set a breakpoint. Let me remove the previous one. Okay, remove the previous breakpoint at line number 13. Can we put a line number 34 right in the beginning of the for loop? Okay, so I'm going to show you exactly how to analyze the loop. So now I'm going to say debug over here. It's going to debug integer array 1. If I click on the debug, okay, so now you can see now we are right at the beginning of line number 34, right before we try to initialize a loop counter, right before that, right? Remember we talked about how to use debugger for the loop. Okay, so now I'm now already on the debugger perspective. Now I want to look at the variables over here. So we already have IA of size 10. Okay, but now if I say step over, it's going to have two things happening. We're going to initialize the loop counter I to be 0, and also we're going to check to see if 0 is less than or equal to 9, in which case it is, so it's going to be true. Okay, so now, however, so let me just do that, and then I can say step over. Okay, so now you can see that we now have over here I is simply the initial value for the loop counter, which is 0. Okay, and I can definitely put things over here. Let me just delete these guys over here. So I'll simply put I here. That's currently for the very first iteration. And then I can certainly put I less than or equal to 9 is going to be true. And then I also have IA integer array at position I. That's going to give me 940, right? This is why we can predict as soon as I execute this line number 35, 940 will be output to the console. Okay. If I say step over here, you can see that 940 is output to the console. Okay, let's do a few more iterations to get you comfortable. Okay, so now what we have is, you can see after that, we're going to, what should we do? We're going to increment the value for I. It's currently still 0. But remember, at the end of the iteration, we're going to increment I by 1. And then evaluate this particular state condition again. 1 less than or equal to 9 should be true. Okay, let's see if that's really going to happen. So now we simply go back to expressions over here. So now let's say step over again. If I say step over, you can see I has been incremented to 1. And 1 less than or equal to 9 will just be true. And now IA at position 1 will just be 880. So that's the second element over here. Okay. So now, okay, the second iteration. If I go for one more. Okay, if I go for one more iteration over here, you can see, okay, 880 has been printed out to the console. Let's do one more. If I say again, step over, it's going to be, the value for I is going to be incremented from 1 to 2. Okay, so now 1 to 2. So now you can see it's being incremented from 1 to 2, and 2 less than or equal to 9 is still true. That's why we are entering this body of the loop again. Okay, let's keep doing this until we get to the, what will be the last value for I? It should be 9, right? Because the last value of I that is going to keep this state condition true will just be 9 exactly. Oh, sorry. It will just be 9 exactly. Okay? As soon as I is incremented from 9 to 10, 10 less than or equal to 9 is going to give you false. That's when we have to exit from the loop. Okay? So now let me just keep going. Okay? Okay, so now I can simply just do this. Okay, you can see just keep saying step over until we reach the last point. Index 9. So now at the moment, if you look at it, the variable I is of value 9. So 9 less than 9 will still be fine. Okay, but now at the end of the iteration where I is 9, we're going to increment I from 9 to 10. So that means as soon as we say step over, it's going to exit from the loop because I is incremented from 9 to 10. And then 10 less than or equal to 9 will just be false. That's why we don't really go into line number 35 anymore. We simply exit from the loop and just go to the end of the program. Okay, hopefully you can see that. Okay, that's about using the debugger and also using this particular version of the for loop. Let me just show you one more version. Okay, this version here works. We simply just use a loop counter over here to really give us the value for over here, the value for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's fine. A more common way of writing the for loop on an array is as follows. Okay, let me just write it down. If I give you any array, okay, IA can be of any size, can be size 5, can be size 6, can be size 10. So now I can say another way that will work. Okay, let me say over here, this is version 1 of using an array to print out all elements in IA. Okay, that's version 1. For now, I'm just going to comment it out. Okay, I'm select that and then comment. So I'm going to say control /. Okay, so now let me just show you the second version. The second version over there, I'm going to say version 2 of using an array to print out all elements in IA. This is the version you want to use. Okay, both work, but I would like you to learn version 2. Okay, so now I can say for, because we know that, let's use I again as an index value for the array. We know that index value for the array always start with 0. I'll say I is initialized to be 0. Okay, use J. Okay. By the way, when you declare the loop counter over here, the scope of the loop counter is only within this particular for loop. That is why if I simply say I is assigned initialized to be 0, that's okay. The I over here and the I over here, they simply refer to different scope, so that's fine. They don't really overlap with each other. but I can just use I still. Okay, so now I can say I, and then I less than. So now what can I do? What should be the last index of the array? Well, we know that the last index of the array should be ia.length, which is 10, and then minus 1, right? Less than or equal to ia.length minus 1, and then I plus plus. Okay, this is a much more general pattern for you to use, for you to learn. Okay, I'm saying that I would just be the index of the array, which always start with 0. That's why I initialize that to be 0. And then what will be the maximum value I can get into? It depends on the size of the array, which would be ia.length. And then the last index is always the size of the array minus 1, because index start with 0. And then every time we simply go starting from index 0 and then to the index 1 for the next iteration, go to index 2 for the next iteration, and etc. Okay, so now I can simply say, let me just copy this line over here for us. Okay, so this will still work, and the same idea as before. You can still try to use the debugger to convince yourself. Okay, that will be an exercise for your own good to be done by yourself. Okay, let me run it again, and I'll show you one more thing, and then we are done. So now if I run it again, you can see that we simply got elements at index 0 up to 9. Okay, everything works. So now I want to show you one more thing. How about this is 2.1? Okay, and then I will put another one which is 2.2, also works. Okay, both are the version I would like you to learn. Now let me comment up version 2.1. I will command /. Okay, so now let me just get all these empty line back, because that'll be the last line on the right. Okay, so now I want you to look at this condition over here. When I say I is less than or equal to ia.length minus 1, I want to rewrite this condition a little bit. I just don't want to type this much. Can I just get rid of this? First of all, think about what's going to happen here. If I say for integer I is initialized to be 0, I less than or equal to ia.length, is this going to work? Why don't we try? If I say run this, apparently we were okay. You can see what's happening here. It seems like we managed to print out indices 0, 1, 2, 3, 4 all the way to 9. But it's saying that there's some exception. So anytime you have an exception, that means you got some logical error in your program. Okay, it's something called ArrayIndexOutOfBoundException. This is the #1 common error you might have when you manipulate with the array, which means you're trying to use an index value for the array that is somehow too small or too large. Too small can be -1, -2. Too large can be, if you're using, for example, in this case, think about what's the largest index here. The largest index over here is simply 9. 9 is not exactly ia.length. ia.length in this case for 10 elements array is simply 10. So if you simply use ia.length as the index, which is 10, you simply go out of boundary. Okay, that is why. Okay, so now the lesson to learn over here is, if I say, okay, let me say version 2.2. Let's say, okay, how about this? I'll change the comment a little bit. I really want to show you the different versions so you really learn from that. This is the version that illustrates a common mistake that causes array index out of bound exception. Okay, that's something you want to avoid. So now what I will do is over here, if I simply execute this program over here, you're gonna get this right here, right? Okay, so now what I want to say is, you can see ia.length in this case is simply 10. That means when i's value is incremented from 9 to 10, 10 less than or equal to 10 will still give you true. That means I'm still going to execute this particular line of code with index value 10. So that's where the trouble is. Okay, write it down for you. Okay, when i's value is incremented to ia.length, in this case, for example, 10. 10 less than or equal to 10 still gives true, meaning that we still execute the body of the loop using IA at position 10. Okay, in this case, right? Hopefully you see that. Okay, so that means the way we write the state condition over here is simply not right. So what should be the last value to use? That means the value over here should not be inclusive. That should be exclusive. Okay, so let me just highlight this particular block and say Control/. Let me do one more version for you. Final version to show you. Okay. So now let me say version number 2.3. Okay, you can just copy and paste. Okay, so now, so either version 2.1 or version 2.3 can work, but you want to know why version 2.2 doesn't work, right? How do I fix it? So now I simply just have to get rid of this, and then I'll simply say that. So now what does that mean? Okay, so now you can see from version 2.2 to version 2.3, I simply take out the equal sign. So that means I will keep executing the body of the loop as long as I is strictly less than the size of the array. In this case, the size of the array is 10. It has to be strictly less than 10. So that means when I go up to 9, 9 is still strictly less than 10. But as soon as I go from 9 to 10, 10 is not strictly less than 10. In that case, I will exit from the loop. Okay, that's kind of the idea. So now, so this will work. Okay, hopefully you see that. So now if I try to execute the code over here, so now you will see that, okay, version number 2.3 will also work. Okay, so actually for this tutorial video, we have seen quite many things over here. I would like you to review very carefully, even though we only talk about approach number 2, which is over here. Okay, try to review everything over here, and then for the next video, we'll get to the assignments approach for initializing an array like this.